Students, we are learning lesson number 7, lenses. And in this lesson, before this, we have studied types of lenses as well as we have studied working of human eye. Also, we have studied. Now, after this, we are going to study about defects. What are the problems into the eyesight or vision? What are the problems into the vision? So what are the defects in the vision and their correction we are going to study. But before this, you should know one thing, that do you know is there, and in that, what is the size of the human eye, or what you can say size of the eyeball. So size of the eyeball or eyeball is spherical in shape. Its diameter is there near about 2.4 centimeter. Again, a lens, eye lens can change its focal length, and we can see the objects at different distances. That object will be nearby, object will be far away, but we can see that objects clearly by changing the focal length, And see, in the relaxed state, if our eye is there in the relaxed state, then focal length of the healthy eye lens is about 2 centimeter, and other focus remains on the retina. Each lens is having two focus. One focus will be there, focal length will be there 2 centimeter, and another's will be there, other focus will be there on the retina. So these things you have to remember. So for that we'll write point. So which is the point that one will see. So do you know in that? So what is given? So first thing is there, size of the eye lens or eyeball. What type of the eyeball is there? First thing is there, eyeball is approximately spherical in shape. Second thing is there, diameter of the eyeball. So what is the diameter of the eyeball? So diameter of eyeball is 2.4 centimeter. How much is the diameter? Diameter is there 2.4 centimeter. So third point is there, eye lens can change focal length. So eye lens can change its focal length, and we can see the objects clearly at different distances. Eye lens can change its focal length, and we can see objects at different objects of different distances. Objects which are present at different distances. Fourth point is there. In that fourth point, what you can say, in the relaxed state, eye lens, in the relaxed state, if a eye lens is there in relaxed state, then focal length of the healthy eye is 2 centimeter, and other focus will be on the retina. In the relaxed state, what you can say, focal length of healthy eye is healthy eye lens, you can say, is 2 centimeter, and other focus is at or on the retina, So we are knowing that focal length, as well as we are knowing two focus it is having. One will be towards objects and another will be there on the retina. Another will be on the retina. So these points are important in the do you know. So next thing is there, try this is given in that what you have to do. Suppose you will take any textbook. That textbook you have to hold far away from your eyes. Try to read it. Second case, you have to hold that textbook extreme close to your eyes. Then try to read. And another thing is there, you have to keep textbook at 25 centimeters and try to read. So in these three cases, in three conditions, if textbook will be far away, you are unable to read it properly. If textbook is so much close, again you are unable to identify the alphabets. But if a textbook will be at 25 centimeter, if a textbook will be at 25 centimeter, then what you can say, you can read that textbook clearly, you can identify that alphabets clearly. So what you can say, near point of our eye is 25 centimeter, and at 25 centimeter distance we can read textbook. Whatever alphabets will be there, that one we can read clearly. So next point we are going to study, and that point is their defects of the vision and their correction. So next point is their defects of vision. So whatever eye defects are there, defects in the eyesight, vision, and their correction, how to correct that particular defects, that one we are going to discuss. So first defect is their nearsightedness. Second defect is their farsightedness, and third defect is their what you can say, presbyopia. And one more is there, that one is their cataract. Another one is their cataract, that one we'll see one by one. So out of four defects, now which point we are going to study? Defects of vision and their correction and their correction. So how to correct that particular defects? So first defect is there, what you can say, nearsightedness. So nearsightedness also called as a myopia. So what is myopia? What is nearsightedness? That one we'll see. So in the nearsightedness, what happens in this defect? What happens? That one will listen properly first, and then we'll write points. First one is there, nearby objects can be seen clearly. In case of the nearsightedness defects, nearby objects are seen clearly, but whatever distinct objects are there, far away objects are there, very far away objects are there, they cannot be seen clearly. So nearby objects can be seen clearly, but far away objects cannot be seen clearly. This is this type of defect. Second point is there, far point is not at infinity. Far away objects we have seen, far point is there at infinity, but in case of this defect, far point is not at infinity, it shifts towards the eyes, closer towards the eyes. Far point shifts closer towards the eyes, and because of that, image of the far away object is formed before the retina, so in front of the retina. So whatever image of the far away object will be there, it will be formed in front of the retina. Instead of forming on the retina, it will form in front of the retina, before the retina. And what are the reasons for that? Two reasons are there. First reason is there, curvature of the cornea and lens. Curvature of the cornea and lens increases, and muscles of that particular lens, muscles of that particular eyes, they cannot relax, so converging power of the lens increases. So what is the reason? First reason is there, curvature of the cornea and lens increases, muscles of the eyes cannot relax, and because of that converging power of the lens increases. So light rays will get converged before retina, earlier than retina. And the second thing is that eyeball elongates, so distance between lens and retina increases. Eyeball will elongate and distance between lens and retina will increase. And the next point is there, that one is there, how to correct that particular defect. So first thing is that these defects can be corrected by using concave lenses. Nearsightedness can be corrected by using concave lenses. Second thing is there, concave lens, it is diverging lens, so it is diverging light rays, and that light rays are converged by eye lens, and that light rays are converged by eye lens on the retina, and image is produced, image is formed. And third point is the focal length of the concave lens is negative, so power of the concave lens will be also negative, and this defect can be corrected by using concave lens. So points will write what is happening in case of the nearsightedness or myopia. First point is there, so you have to remember nearby objects can be seen clearly, but far away objects cannot be seen clearly. First point is there, nearby objects can be seen clearly, but far away objects cannot be seen clearly. Far away objects cannot be seen clearly. Second thing is there, so far point of the object, far point of the eye, which is at infinity, it shifts, it is not at infinity, it is shifting towards the eye. Okay, so far point of eye shifts towards or closer to eyes, you can say closer to eye. Far point shifts closer to the eyes, Third point is there, in that what you can say, image of the faraway objects, forms in front of retina. Image or images of far away objects forms in front of retina, or before a retina, you can say, or before retina. And for that some reasons are there. What are the reasons for that? Nearby objects can be seen clearly, far away objects cannot be seen clearly. Far points of the eye shifts closer to the eyes. Then images of the objects, far away objects, forms in front of the retina, before retina. And now reasons are there, reasons for nearsightedness. So first reason is there, curvature of the eyeball, curvature of the retina, or also you can say cornea, curvature of the cornea and the lens increases. Curvature of the cornea and lens increases, and so muscles of that particular eyes, muscles of the lens, they cannot get relaxed, so converging power increases. So what is the first reason? Curvature of cornea and lens increases. Muscles of eye lens cannot get cannot get relaxed. So converging power or you can say converging power, also you can say converging power of the lens increases. Converging power of lens increases. What is the point? Curvature of the cornea and lens increases. Muscles of the eyes cannot get relaxed, so converging power of the lens increases. Second point is there. So eyeball elongates, so distance between lens and retina increases. Eyeball elongates and distance between retina and lens increases. Distance between lens and retina increases. And now correction. What will be the correction? What will be the remedy for it? Correction. So in the correction, what you have to do? You have to use to correct this defect can be corrected, or you have to use convex lenses. So first point is there, to correct this defect concave lenses are used. Second point is there, in that concave lens diverges light rays and eye lens converges light rays on the retina. Concave lens diverges light rays and eye lens converges light rays on retina. And third point also, you can tell focal length of the concave lens is negative, so power of the lens is also negative. Focal length of concave lens is negative, so power of lens is also negative. So you will get negative number, minus number you will get. So these are the points related to nearsightedness. One more time, see what are the corrections, how you can correct this defect. To correct this defect, concave lenses are used. Concave lens, here you can write concave lens diverges light rays and eye lens converges light rays on the retina. Focal length of the concave lens is negative, so power of the lens is also negative. So next, in this diagrams are there, and diagrammatically we will study. So diagrams, after writing these points, you have to draw the diagrams for nearsightedness. So what are the diagrams and how that diagrams you have to draw, that one you have to see, and you have to also draw the same diagram. So first thing is there, suppose we'll draw like this way structure of eyes. Here will be cornea, here will be lens, eye lens will be there, and this one will be retina, and this one will be eye lens, and eye lens is there convex. So first thing is there, suppose object is there nearby, then no problem. If object is there nearby, then no problem. So that light rays will be converged at single point on the retina, and here image will be formed. So nearby object nearby objects. No problem. For nearby objects there is no problem. Now this one is the diagram number 1. You can give diagram number 1. Second diagram, for far away objects we have to draw the diagram. So like this way you will draw the diagram. Suppose this one will be the lens, this one will be the retina, this one is their lens, and light rays are coming from far away objects. Here is the problem. So what happens? Converging power of this lens increases, so that light rays are converged before retina only. That light rays are converged before retina. So like this way, and they will converge here only, middle only. That's why image is not formed. And this one is there, which type of eye? Myopic eye. Myopic eye is there. To correct this disease, to correct this defect, we have to use concave lens. And if you will use concave lens, then what happens? That one I am going to draw here. So see, third diagram, after correction, after using, second diagram is there. Third diagram you have to draw. This one will be cornea, this one will be eyeball, then here will be lens, convex lens will be there. You have to use concave lens here. Then what will happen? Light rays which are coming from far away objects, that light rays will be diverged. They will get diverged. Okay, and after divergence, that light rays will be diverged, and that light rays will be collected, or they will converge on the retina. They will get converge on the retina. So this one is there, concave lens. Light rays you can show this diverge. So like this way also you can show diverge light rays. And so what will happen? Its focus will be here. So like this way, if you will correct, if you will use concave lens, then this one is their eye lens is there. This one is their eye lens, and here is their retina. So by using concave lens we can correct this defect. So these three diagrams you have to remember. Here light rays are diverged, and again that light rays are converged by eye lens. So this one is their defect related to the nearsightedness. Next defect we are going to study, and that one is their farsightedness. So that one we'll see. Second defect is their farsightedness. So in that farsightedness, we'll see what happens, what are the problems, what are the reasons, and what is the corrective method. So second type of defect is the farsightedness. Also you can say for farsightedness also hypermetropia. You can say hypermetropia, and it is exactly opposite to the myopia. So what will happen? First we'll see points related to this one, and then a correction, and then diagram. So first of all, in the farsightedness, far away objects are seen clearly, but nearby objects are not seen clearly. Far away objects are seen clearly, nearby objects are not seen clearly. Second point is there, near point shifts away from eyes. Near point shifts away from the eyes. Okay, near point shifts far away from the eyes. That's why this defect is arising. Third point is there, image of the nearby object. Image of the nearby object is formed behind the retina. Backside of the retina. So what are the reasons for that? First reason is there, So eyeball, so in case of the eyeball, what will happen? It will become rounded shape, more rounded shape it will become. So what will happen? So focal length, whatever focal length is there, or what you can say, converging power is there, it will decrease, and diverging power will increase. Converging power will decrease, of that eye lens converging power will decrease, diverge, and light rays will get diverged, or what you can say, they will not be collected on the retina, they will not meet on the retina. Next thing is the eyeball. In case of the eyeball, that eyeball, in a nearsightedness we have seen there it get elongated, but here it will become rounded shape, round shape. So distance between lens and retina decreases, so image is formed after the retina, behind the retina, you can say. How to correct that particular diseases? First thing is that this defect can be corrected by using convex lens. Second thing is that convex lens is having converging power, more converging power, so light rays will be converged first, again that light rays are falling on the eye lens, again that light rays are converged on that particular retina by eye lens. And one more thing is the focal length of the convex lens is positive, and that's why power of the lens will be also positive, and that diagrams we are going to draw. So one by one we'll see what are the points related to the farsightedness. First point is there, so far away objects can be seen clearly, but nearby objects are not seen clearly. Far away objects are seen clearly, but nearby objects are not seen clearly. Second point is there related to the near point of the eye. Near point of the eye shifts away from the eyes, near point, which is 25 centimeter, near point shifts away from eyes, Third point is there, so image of the nearby object is formed behind the retina, after the retina. Image of, or images of nearby objects are formed behind the retina, or what you can say, in front or back side of the retina also you can say. What are the reasons for it we are going to study? First reason is there, what you can say, curvature of the cornea and lens decreases. Curvature of cornea and lens decreases. Curvature of the lens and cornea decreases. Also what you can say, converging power of lens decreases. Converging power of the lens also decreases. Second reason is there, eyeball becomes more rounded, so distance between lens and retina decreases. Eyeball becomes more rounded, so distance distance between eye lens and retina, eye lens and retina decreases. So these are the defects, these are the reasons. And next thing is their correction. So correction, what is the correction for this defect? First correction is there, this defect can be corrected by using convex lenses. This defect can be corrected by using convex lens or convex lenses. Second point is there, convex lens, it is having a converging power, so it will converge the light rays first, then again eye lens is also converging light rays on the retina and image will be formed. So convex lens converges light rays, and eye lens converges light rays on retina and image is formed, and the third one is there, focal length of that particular convex lens is positive, so power of the lens will be also positive. Focal length of convex lens is positive, so power of lens is also positive, so your number will be there positive. So these are the points related to the what you can say, farsightedness or hypermetropia. So diagrams we are going to draw about this one. And what are the diagrams? So first thing is there, we'll draw diagram for far object and then correction. So suppose this one will be cornea, this one will be eyeball, there will be the lens, eye lens will be there, then light rays which are coming from far away object. There is no problem for the convergence. Light rays which are coming from far away objects, they will be converged on the retina. This one is there, retina, on the retina it will be converged. This one is there, eye lens. And for far away objects, there is no problem. This one is the diagram number first, suppose. Second thing is there, defect. So here what is happening, suppose eye lens is there, light rays which are coming from the nearby objects, what will happen, they will not converge on the retina, they will be converged behind the retina, so image will not be formed. So what you can say, hypermetropic eye, or defected eye. This one is the diagram number 2. This one is there, eye lens is there. Here will be retina and here will be image is formed behind your retina, and this one is there for nearby object, and this defect can be corrected by using convex lens of appropriate focal length. So third diagram I will draw here. But while drawing diagram, you have to use scale, pencil, and compass. So suppose, see here will be retina, so cornea, retina, and here will be eye lens. So suppose light rays which are coming from the nearby objects, suppose initially one convex lens we are going to use here, that light rays will be like this. That light rays will be converged by this lens, and then that light rays will be converged by eye lens on the retina. So light rays are converged double or 2 times. So here is their convex lens, this one is their eye lens, and here will be retina will be there, and here image will be there. Image will be formed on the retina. So this, like this way you can correct the defect. Okay, so these 3 diagrams are most important. On while explaining any type of defect, you have to draw 3 diagrams, and here correction, you can say corrected or correction by using convex lens. 3rd diagram is there. So after this, next defect we are going to study, and that next defect is there, that one is there presbyopia. In that presbyopia, what is there, that one will see. Presbyopia, so that defect is arising in case of the persons, old age persons, those who are having more age, for them this defect is arising, presbyopia. So in that, the 3rd one is there presbyopia. So in that, we'll see, due to the old age, focusing power of the lens decreases. Again, one more thing is there, eye muscles, they lose their ability to change the focal length. 3rd one is there near point shifts away from the eyes. 4th one is there, sometimes what you can say, in case of due to the old age, both the defect are arising. Nearsightedness is also arising and farsightedness is also arising. In such cases, bifocal lenses are used. Which lenses are used? Bifocal lenses are used. In that, so upper side and downside, 2 lenses are there. In the same spect, 2 lenses are used. So upper side we are using a concave lens, and lower side we are using convex lens. Upper side it will be there for nearsightedness, and lower side, that convex lens will be there for farsightedness. So that one will write the points. First thing is there, due to old age, focusing power of the lens, focusing power of lens decreases. Second point is there, in that eye muscle lose their ability to change the focal length. Eye muscles lose their ability to change focal length. Third point is there, near point shifts far away from the eyes. Near point shifts away from eyes. Then a fourth point is there, sometimes due to old age, both nearsightedness and farsightedness defects occurs. And the fifth point is there, to correct this defect, bifocal lenses are used. Bifocal lenses are used. So in that, first thing is there, upper part concave lens is used. For what purpose? Nearsightedness. And second is there, lower part of spect. For that, convex lens is used. For what purpose? To correct farsightedness. So like this way, presbyopia is there, and one more is there, cataract. And in that cataract, what is happening? On the cornea, layer becomes thick and it will be removed. It is removed by doing operation, cataract. That one we will see later on. But after this, we are going to study about next points. Which next point we are going to study? In that, uses of concave lenses and uses of convex lenses, and that one we will see in next video.